Well, I promised. Got two things to compute. One is the chance of drawing a certain kind of card hand. And the other one is counting number of words with repeated letters. These are fun little puzzles that you might have seen growing up. Or maybe you're seeing it for the first time now and you just wondered how you would do this. So here's the card hand I'm thinking of. It's a full house, aces high, kings low, or three, I guess, I don't know what they call it, 3 aces, 2 kings. Pretty much the best full house you can get, because the 3 of a kind is the highest card you could use. And then the 2 of a kind is the next highest card, so it's a pretty good hand, beats almost every hand. So what's the chance of being dealt 3 aces and 2 kings off the deck? No swapping of cards, no nothing. Well, we have to decide how many kinds of hands there are like that and how many total hands there are that are equally likely. So to find out how many hands, first we'll pick the 3 aces we're going to choose. Well, picking the 3 aces is the same thing as not deciding which ace not to pick. There's 4 aces. Or you say 4, choose 3. There's 4 ways. And then you have to pick 2 kings out of 4. Here's the 2 kings out of 4. There are 6 ways to do that. And then that's one thing followed by another. So there's 4 ways to pick aces and 6 ways to pick kings. So there's 24. 6 times 4, 4 times 6 is 24, whatever, ways to get a hand. So not very many full houses with aces and 2 kings. 24 possible hands. The total number of hands you could be dealt from the deck is 52, choose 5, since you don't care about the order. It's a pretty big number. Look at this, it's 2.5 million hands. So it would take a long time to see all possible hands, that's for sure. The probability of being dealt this particular hand is 24 ways divided by the total number of ways you can be dealt. And so when you punch that in, you get a bunch of zeros. 1, 2, 3, 4, 5 zeros, then 2, 3, 0, 8, 6, 1, 5, like that. So about 1 in 100,000 hands. So it's not impossible, but that's a pretty small chance that you'll get dealt aces and kings in full house, and your 5 cards you get right off the top of the deck. 1 in 100,000. And then, so that's a nice calculation. The next calculation is how many 11-letter words can you make from the letters in this 11-letter long state name? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to rearrange the letters in Mississippi. Imagine that they're Scrabble tiles. I'm going to rearrange them. In fact, thinking of Scrabble tiles, I think Scrabble tiles sometimes have these little subscripts on them. I can't remember, but if we go ahead and put subscripts on the letters so we can tell them apart, you can think of doing that. M doesn't need subscripts because only one M, but there's 4 I's, so we do I1, I2, I3, I4, and there's 4 S's, I1, S2, S3, S4, and 2 P's, P1, P2. So now they all look different. So we know if we want to rearrange K items, and they all look different, the number of ways you can rearrange them is K factorial. So if the letters look different, we get 11 factorial possible words from these letters where they're all different. Okay, so that's one way to think about it. The other way to think about things is, let's just take a word from Mississippi that's different from Mississippi we get by rearranging Mississippi. And then, so what could it look like? Well, it could look like this. Maybe all the S's come first. We decided to be easy about it. A couple P's, then the I's, then the M, like that. So there's a rearrangement of Mississippi. It's 11 letters, just in a different order. And we want to know how many of these kinds of things we can make. We know how many of rearrangements we can make of that. So we want to see if we take this, can we turn it into this, right? So what we're going to do is we'll just put the subscripts on here in some way. There's 4 factorial ways of assigning subscripts to those S's. So we have to pick which letter gets the first subscript, which letter gets the second and third and fourth. So it's 4 factorial ways. And then to do the same thing here too. There's two ways to do that. And we'll do it here too. All kinds of ways to do 4 factorial. So and there's only one way to, this is already okay, as is, right? So we add subscripts. That gives you 4 factorial from the one word multiplies that number of words by 4 factorial, then by 2, and add these subscripts, then by 4 factorial again, which is 1152. So you get, for each rearrangement of Mississippi, we get 1152 subscripted Mississippi words. All right. So then we write this down. We say if there's n possible arrangements of Mississippi, for each one I get 1152 subscripted words. I take the n, so count the number of rearrangements, each one of them multiplied by 1152 ways of adding subscripts. And that should give me a product that's equal to 11 factorial. That lets me compute the number of different arrangements of Mississippi to be 11 factorial over 1152. And it comes out to be an interesting formula. 1152 is all these factorials. So take a look at this. This 11 here is the number of letters in the word. So if all the letters were different, I just get 1150. I would just get 11 factorial. These duplicated letters down here show up in the denominator. Each possible letter, the number of times it shows with the factorial next to it. So the M was 1 time, 4 S's, 4 I's, and 2 P's. So these 8, 9, 10, there's a 4 plus 1 plus 2 is 11. So these are all the 11 letters represented. This is the number of times this is the number of times each repeated letter shows up. And these factorials have to do with applying the subscripts to those letters. That's the number of ways you can make a subscripted word. And so since those subscripted words look the same when you take the subscripts off, we take the number of subscripted words and we divide by those factorials to get the number of unsubscripted words you can make from Mississippi. So that's a separate way to think about it, kind of in reverse order. So if you've got a question about how many words can you make from a given word that's got repeated letters, you put the number of words, number of total letters factorial up there, and then you put all the number of repeats with factorials next to them in the denominator. And that product, that quotient, gives you the number of words without subscripts you can make from the letters. So this is sometimes called a multinomial coefficient, in case you run into it in your life. Nope, I can't write today. Shouldn't use pink and try to erase, but whatever. Multinomial coefficient. So if you wanted to go online, go to Wikipedia, you could type in multinomial coefficient. It'll tell you all kinds of things about multinomial coefficients if you want. And that ends this section. And a few more slides have been demolished. And we're making our way to the end of the class, but it's still a ways away. And we'll be seeing you later.